Alright, let's get back to it. These are the multi-part problems with the roller coaster hill, the first problem. Alright. We already found out that the kinetic energy at the top right over here is 0 because the velocity is 0. Now, we also know that the potential energy is mgh. We have some info here about the mass of the car. We know g is always 10 meters per second squared, or 9.8. Here we know that the height is 35 meters. So here, if h is equal to 35 meters, then the potential energy has to be equal to mass, which is 120 times g, which is 10 times 35, which is h. So it should be around 42,000 joules. All right, so that's also the total energy, because remember, E total is equal to PE plus KE. In this case, if there's no KE, the E total is just all potential energy. Cool. Now, this is the great thing about these problems, is because once we found out the potential energy or the total energy at the beginning, we know that it has to stay the same throughout. So here's an easy box to fill for all 4 of the points. 42,000 joules. Now, we also know that we can find the potential energy at each of these points by looking at the height. So at point 2, the height is 0. Point 3, the height is, I'm just going to write in the heights first. The height is 28 meters. And point 4, the height is 15 meters. This one's point 2 is pretty easy, because if the height is 0, then the potential energy has to be 0. That means that you know that all of the total energy here goes into the kinetic energy. I'm just going to fill out the easiest things first and then move on. We know the potential energy here has to be mgh again, so 120 times 10, but now the height isn't 35, rather it's 28. So the potential energy here is 33,600. Kinetic energy has to be the difference, so 42,000 minus, so the kinetic energy has to be 8,400 joules. We also have to find the potential energy down here. 120 m times 10 times the height of 15, 18,000, and then the kinetic energy has to be 24,000 joules. All right. Now for each of these problems, we can also find the velocity because we have the kinetic energy at each point. So KE is equal to 1/2 v squared. Or, when we rewrite this, we can also say v squared is equal to 2ke, mv squared is equal to 2ke, or v squared is equal to 2ke divided by m, or v is equal to the square root of 2ke over m. So there's a little bit of algebra that we just did to figure out what the velocity is in terms of kinetic energy and mass. Alright, so for each of these, all I need to do now is just multiply the kinetic energy that we have times 2, and then divide by the mass. That is correct. So divide by the mass, which is 120. So for number 2, the velocity should be around 26 meters per second, 26.5. For the one below that, could I do this again? 2 times the kinetic energy, 8,400. This is a little tedious, but it's nothing that you can't do. And y'all can't take care of. 12 meters per second to 2 times divided by 120. Boom. That's problem number 1. Roller coaster hill. Alright. Let's give it a check plus, and let's move on. Number 2. So that took me around 4 minutes. Okay. Swing set with the pendulum. Alright, so now over here, we are looking at a pendulum, and we know that there are 3 points, x, y, and z. If we're looking at points x, y, and z, we have some information here regarding the mass of the man, the velocity at point x, the height at point x, and the height at point y. So here I'm just going to write in height at point X and Z, h is equal to 4 meters over here, and h is equal to 4 meters over here. I also know that at y the height is 1.5 meters. It's not 0. Okay, that's really useful because this is very, very similar to the last problem that you guys just worked on. It's very similar to the roller coaster problem. So the way that we're going to approach this problem is first to find the potential energy at the very beginning. Remember, potential energy is mgh, and kinetic energy is 1/2 mv squared. So to find, if we know that the velocity of the man at point X is equal to 0 meters per second, right over here at the very beginning, he starts from rest. That means that if the velocity is 0 meters per second, kinetic energy is 0 joules. That also means that whatever the potential energy is at the beginning, that must be equal to the total energy. They're the same rules that we just went over. So PE is equal to mgh. I'm going to throw this into my calculator. We'll see the mass of the man is 95, g is 10, height at X is 4 meters. So then we get 3,800 joules. That must be the total energy as well. Now, just like the last problem that we worked on, every single one of these total energies is going to be the same. Or, I guess at these 2 points. Now, that doesn't mean the potential energy is the same, because we know that the height is a little bit lower here. So, total energy is still 3,800, but the height is lower, so it's actually 95 times mg times 10 times 1.5. So it's 1425 joules. The kinetic energy is 2375 joules. And we know that 2 times Ke, using the same formula we used last time, 2Ke divided by m, the velocity should be around 7 meters per second. Now, his friend gives him a push doing 300 joules of work to the system. So that means you add 300 joules. 300 joules of work, remember, work adds. If you're adding energy, you're going to be doing positive work. So that means that if you're adding 300 joules, you're going to have to add that to whatever the total energy is up here. So 4,100 joules. That's 3,800 plus 300. So that means the highest point above point Z is now going to be a little bit higher because there's more energy. But at that highest point, if the velocity is 0 meters per second, the kinetic energy is still going to be 0 joules, and the potential energy is going to have all of that 4,100 joules. So mgh, PE is equal to mgh, which is equal to 4,100 joules, and UH is equal to 4,100 joules divided by mass, which is 95, times G, which is 10. So then we'll end up with 4,100 divided by 95 times 10. That gets us a height of 4.3 meters. So the height is actually 0.3 meters higher than the highest height before. When you add 300 joules of work, you actually push them up a little bit and you get even more work. Or you get even a higher height. Let's see. That is boom! Cash money. Check number 2. Alright, finally, last problem, GP stair climber. Oh, you guys are going to be so well prepared for this test, I can't even wait! Okay. We got a Power Ranger. Let's draw him in a little bit of red. Pachoom, pachoom, pachoom! You see, he's red. Alright, so the Power Ranger. Could you just take a second to appreciate how funny this is? I really worked hard on this one. Okay. Now, we have some information here about the mass of the Red Ranger, the velocity at the top of the stairs, the initial velocity at the bottom of the stairs, and the height of the stairs, 9 meters. Okay, so at the bottom of the stairs, kinetic energy is 0 joules, because he hasn't started running yet. So at the very beginning, he's 0 joules. The potential energy is also going to be 0 per K, because the height right here is equal to 0 meters. Right? He doesn't have any height yet. At the top, this height is 9 meters. But at the bottom of the stairs, his height is 0. Right? So no potential energy. This is 0 joules. No total energy either. He just has no energy. He's feeling kind of lethargic or lazy. That is an SAT vocab word for you guys who are taking SATs. At the top of the stairs, however, he does have some potential energy because he has a height. So mgh is equal to 50 kilograms times 10 meters per second squared times a height of 9 meters. So that should be around 500 times 9. 50 times 10 times 9 is around 4,500 joules. So at the top of the stairs he has 4,500 joules. If he has no kinetic energy, that has to be the total energy as well. Okay, let's do number 3. What was his change in energy? Okay, so the change in energy is equal to the final minus initial. We know he started with 0, so the change in energy has to be that 4,500 joules. It's not any different than what his final energy at the end is. What was the work done? Same thing, baby. Change in energy is the same thing as work, like we just described in our table in the beginning. So if you climb the stairs in 17 seconds, what was his power output? Okay, so P is equal to work divided by time. If he did work of 4,500 joules divided by time, 17 seconds, we get a power output of, geez, it's pretty impressive, Red Ranger, 265 watts. That has the power of approximately 4.4 light bulbs. So as Red Ranger runs up, he can light up 4 light bulbs. Those are light bulbs, obviously. Alright, the Red Ranger wanted to be super powerful, oh crap, super powerful, and have a power output of exactly 900 watts. How much time would he have to take to reach the top of the stairs? Okay, so this is a little bit tougher because we know the power is equal to 900 watts for sure, or we want a power of 900 watts. We know that work isn't going to change. That work is still going to be 4,500 joules. We know that because the Red Ranger's mass isn't going to change. MGH, right? We know the mass isn't going to change, G is not going to change, it's always 9.8, and the height isn't going to change either. That staircase is always going to be 9 meters. The only thing that's going to change is the time. So if P is equal to work divided by T, we need to solve for T. So T is equal to work divided by P. And then work divided by P brings it down over here. Okay. So we know that work in this case would have to be 900. Oh my gosh, I'm sorry. See, even I get confused. The work would have to be 4,500 joules, right? The power would have to be 900 watts. And that would tell us that at the end of the day, he needs to do that 4,500 joules of work in 5 seconds to get a power output of 900 watts. That is problem number 3, and these are the only 3 kinds of problems that you'll see on your test. So what I would do is make sure that you can follow the procedure for solving these problems in the video. Make sure that you can follow my process for all of this. If you can rewind, that's the beauty of the video. You can rewind and go over any of these that you have questions with. If you have any questions for me that you need answered in real time, please let me know via text, email, message, whatever. Alright? Happy studying. You guys got this.